You're listening to Beyond Wellness Radio, bringing you the cutting edge in health, biohacking, and sports performance. Stay up to date and listen anywhere and anytime on your computer, tablet, or smartphone by subscribing on iTunes. Catch your host, Dr. Justin Marchegiani, as he answers your burning health questions as well as interviews from world-renowned guest experts. For more Beyond Wellness Radio, go to beyondwellnessradio.com.
Hey there, it's Dr. Justin Marchegiani. Welcome to Beyond Wellness Radio. Feel free and head over to beyondwellnessradio.com where you can access our full podcast transcriptions. While you're there, you can also sign up for our thyroid and female hormone video series. This series goes into the root cause of why your hormones are out of balance. While you're there, you can also schedule a functional medicine consult with Dr. Justin, myself, where we'll dig deeper into the root cause of your health challenges. Feel free and think of sharing this podcast with at least one person. This podcast grows by people sharing it. Sharing is caring. If you can think of one person that can benefit from this information, please feel free and share it. If you're enjoying the podcast, make sure you subscribe on iTunes. You can also click below the video or podcast where you'll see the iTunes review button and leave us a review. You can also sign up for the newsletter at beyondwellnessradio.com where you'll get updates before anyone else. Thank you so much and enjoy the show. Hey there, it's Dr. Justin Marchegiani. We got Dr. Andrew Hill on the show today. Dr. Andrew's a grad over at the UMass Amherst School there. I went to school there as well, so we're fellow alums. Also a PhD grad over at UCLA. Dr. Hill, it's been a while, but it's glad to have you back on the show.
Yeah, thanks for having me, Justin. I'm guessing a lot has happened for Beyond Wellness as well as on my end of things the past couple of few months.
Very cool. I'm excited. What's new in your neck of the woods?
We are, a new company I've been working on called Peak Brain. We've been opening up brain training centers, neurofeedback centers. We're also doing a lot of free mindfulness instruction. I'm sure we talked about this last time. We sort of view a lot of different aspects on, call it biohacking, call it therapy, call it exercise. There's lots of different avenues into this space. And for many people, different choices might make more sense. Choices, free things like mindfulness and meditation, where you're always carrying around the equipment. Once you know how to do it, you can always practice. I have this focus at this point of bringing tools to accessible, or bringing accessibility to people. So the idea is to provide a lot of open mindfulness instruction in these training centers, as well as the higher tech tools that people can sort of buy services in, getting a lot of hands-on training in QEEG and neurofeedback. So I'm taking it more to the fitness level and out of the clinical level as much as possible these days.
And are you doing more EEG or neurofeedback work?
Yeah, the most of the neurofeedback we do is EEG based.
Okay, got it.
Neurofeedback or biofeedback. We also do HEG, which is another form of neurofeedback. We do a little bit of HRV, which is biofeedback peripheral. Let me break those down for 1 second. There's some overlap in terms. All neurofeedback is a form of biofeedback, but not all biofeedback is neurofeedback. The difference really, the central nervous system, as you know, as a pretty savvy guy about the body, is central nervous system is everything encased in bone, essentially. So all the nerves that are inside the spinal column, the brain, etc. And everything outside is peripheral nervous system. And so broadly, you can define neurofeedback as central neurofeedback or peripheral biofeedback. And that's sort of the line that ends up getting drawn. That's a little blurry because you can do things centrally like HEG, where you're training blood flow voluntarily, and EEG is a form of central biofeedback where it's involuntary shaping. So the lines blur very quickly because the body is not divided into discrete compartments that are purely isolated from each other in these systems. So it's a little bit complicated, but there's probably more information than you needed on the differences.
Very cool. So if someone is out here, maybe they have excessive sympathetic nervous system overdrive or an adrenal dysfunction, right? Neurofeedback and or EEG tend to be a really good way to dampen that oversympathetic, over fight or flight response that's happening. So if someone's having that, they're making the diet and the lifestyle changes, maybe they're on an adrenal program using some adaptogens and nutrients, and they're stabilizing their blood sugar, making themselves be more a fat burner. Would the next step be, if they're doing all these things correct, how would they incorporate the EEG neurofeedback into their life?
Yeah, the next few steps in terms of adding tools and technologies to support health as well as transformation would be probably to add in either peripheral biofeedback tools like HRV, like galvanic skin response, like mindfulness, like meditation practice, and then I would say the next level is adding in the sort of higher tech tools like the EEG neurofeedback. And to enter that stage, and if there's a problem, I mean, for the average person who's working on stress management or just trying to optimize peak performance, you really want to build these things so you have a good foundation. If you're trying to remediate a specific issue, you have seizures, you have ADHD, you have some, problem that's really getting in your way, then you can go right to neurofeedback, I think, is a, first line intervention. And for something like that, you start with what is called a brain map, a quantitative EEG, ideally. And those are usually baseline assessments of brain activity that are then compared to a normative database. And out of that, you get maps that tell a practitioner like myself how unusual you are compared to a population. And then we examine the most unusual aspects of your brain, how it's functioning. And some of those tend to cohere with certain functional limits or patterns or bottlenecks. You may notice I'm using a lot of very tentative language, and that's because the QEEG is not neuroimaging, it's statistical analysis. It's you compared to some distribution of continuum of function, so it's really you compared to a bunch of different average people, and your brain can be special and unique and wonderful and really unusual and still be fine. So QEEG is as much of an art as it is a science. There are a few things in the EEG and the quantitative EEG that are well validated, sort of diagnostic markers or other, we call them discriminants. Pretty reliably, if you have clean EEG, you can spot traumatic brain injuries in people if they're at all significant. You can often or almost always actually spot ADHD. The FDA has a pretty good, at this point, support of a few discriminants in the EEG that suggest ADHD, including going so far as to support a hardware diagnostic headset a couple of years ago as actually diagnosing ADHD passively without any clinical involvement. And essentially it's doing I believe it's doing looking at ratios of frequencies in the brain. So you start with these assessment tools to get a peek under the covers. And this has a quantified self implication as well as a, remediation benefit. And you get a sense of how your brain works. And then the next step is to start exercising and training it using, biofeedback essentially. And we shape brain activity and figure out how that affects function. And over time, you make changes to the brain. I know we talked about this before, but it's essentially operant conditioning, not you could think Skinner, not Pavlov.
Yeah.
So we aren't making a voluntary response happen by providing a random thing like the bell and pairing it with some stimulus.
Exactly.
What we're doing is instead only rewarding certain stimuli you do. So Skinner's less well known than Pavlov, but I think it bears expanding. Skinner trained essentially pigeons to peck on bars or do certain behaviors to get rewards, to turn a light on or, hit a switch or something. And a Skinner box is a behavior shaping device. You don't just examine how pigeons behave, you examine how they learn. So you're shaping or changing a behavior. And the way you do that in operant conditioning is you reward behavior that is near what you want to accomplish. So you find what the brain is doing moment to moment, and then when a certain brainwave moves a little bit or trends in the right direction or stays in the right direction, that's when you provide the reward. So over time, you're shaping, you're rewarding a different trend. Yeah. Mm-hmm. And then you move the goalposts and you reward further, development of the trend, the physiological trend in that direction. The weird thing about the analogy of Skinner versus Pavlov, this is operant conditioning. However, the pigeon knew what it was doing. It was, it was trying different things. Pigeons actually can get very superstitious. If they spin around once and then get rewarded, they will then spin around once as they approach that food bowl and switch again because they've learned. Pigeons are like baseball players. They're so superstitious.
Yeah.
It's a little ridiculous.
That is funny.
But in the case of EEG, the analogy breaks down because what you're rewarding, the behavior, if you will, of the brain is fluctuating EEG that's happening in a time course that is faster than you can perceive or control. So it's really measuring sort of the real time, under 100 millisecond sort of time window of what's fluctuating in your brain. And you don't really control things in that time course. You're really perceiving in the 90 to a couple hundred millisecond time frame for most of us. We don't perceive rapidly. We don't perceive most of what's going on, neurologically. And so as it's fluctuating, you reward it and shape it, and over time it changes, which is kind of magical and lovely. But it's not the magic of neurofeedback that's doing that. It's the magic of the brain. It's the brain's ability to interpret a signal, a shaping signal. It's the brain's ability to enhance its plasticity in response to a signal. There's really good evidence now that neurofeedback ramps up plasticity fairly profoundly. Something called an evoked motor potential can be used to measure plasticity of cortex. Essentially, you use transcranial magnetic stimulation to zap a little bit of the brain and see, over the hand area of the motor cortex, and see how much voltage it takes to make the hand jump.
Got it.
It sounds brutal, but it's actually a fairly innocuous little thing they do with TMS, just to see if they're over the right area. There was an experiment a couple years ago that showed that before and after neurofeedback, the motor cortex responds to a much lower voltage, a much lower signal before it perturbs, before it jumps and responds and changes. And so this is a sign of motor plasticity or learning, broadly, that seems to be upregulated fairly rapidly with neurofeedback.
And when you're saying
other evidence of this,
and when you're saying neuroplasticity, basically your brain is almost starting to rewire itself, essentially.
Yeah, it's rewiring itself. I think of it sort of like it's getting younger, because for many of us, we've had the experience of being, over plastic. I mean, that's what being a teenager is to some extent. Things just change a little, too rapidly, and you swing. But there's this proliferation of synapses, of connections between neurons in early teen years, 10 through 14 or 9 through 14. Around 9 or 10 or 11, the brain sort of finishes a lot of its lateralization. That's when a lot of final development happens. Post that age is when language acquisition without an accent becomes very difficult. But right after that, there's this proliferation for a few years of synapses, massive, overbuilding in some ways. Think of it like a forest that is becoming so thick and so overgrown that it just doesn't have a lot of light getting through it. It's almost like too much in terms of synaptic density. And then there's a big period of learning where those synapses change wildly in mid-teen years. And many of them get pruned away. This neuropile, as it's called, gets pruned away into more discrete circuits. And that's a time of profound learning and skill development and self-regulation and other things in those mid-teen years. And so I really do think about, the plasticity enhancement features of neurofeedback as sort of rolling back some of the decline of synaptic flexibility that was so prevalent when most of us were in our mid-teen years, when things were just changing and responding and changing and responding, and learning was like trivial. We could just learn and change and grow and develop, and it all seemed effortless, relative to how things feel, 20 years later, or 30 or 40 or 50 years later. So that's my goal from all this stuff, be it nootropics or meditation or neurofeedback, and be it for whatever goal, peak performance, substance abuse, remediation, if you will, changing your relationships, and you're in control over substance behavior, which is how I prefer to think about it. Getting control of executive function, getting control of aging, getting control of mental illness. These are equivalent in my mind. They're all about getting some control over this 3-pound blob that uses most of our, glucose and oxygen resources in our body. And learning to take, a little more active role, if you will, in how it develops, how it changes, how it has a trajectory of improvement and aging and learning and growth. So a lot of my focus has really swung hard towards encouraging and supporting people's access to these tools.
Interesting. And you mentioned a couple of things, especially with ADHD. And it's interesting when you compare and contrast, the functional, more natural alternatives, EEG, nutrition, functional medicine for, like, let's say ADHD. You also have the conventional options, which are pretty mainstream, but they typically involve stimulants, methamphetamines, Adderall, Prozac, those type of medications where you're trying to overstimulate the brain into focus, into the ability to pay attention. How is that different? I mean, obviously, one I see is whipping a tired horse. The other one is much more different and is trying to align the brain in a more functional, more sustainable way. Can you compare that?
Interesting analogy. Let me talk about medications for a second. Now, I'm not a psychiatrist. I'm a neuroscientist, but I know a thing or two about pharmacokinetics and dynamics and how they work. In theory, they should not be working. Psychostimulants should not be working by whipping the tired horse. In theory, the CEO of the company is asleep under the desk, and the psychostimulant is like the cup of coffee that gets them to be productive again, so they control all the random nonsense going on in all the different departments of the company.
Right.
So it's waking up an executive that is not controlling things versus driving an already tired system. I just want to, I want to shift the metaphor a little bit because there's a couple other classes of drugs that are now used. You mentioned SSRIs, I think.
Yeah, Prozac.
Prozac. That is used sometimes, no longer very much in kids and teens because the suicidality increased risk is pretty high now. They've discovered with SSRIs. That's often not a great course. But the other two classes that are used, some of them promising with some promise, are mood stabilizers and beta blockers, blood pressure meds. And a couple of the blood pressure meds that are being used really seem to work for some of the most acute behavioral symptoms.
Are they beta blockers? Are they helping to decrease that action potential in the heart and the sympathetics? Is that how it's working?
I'm not sure how they're working. Things like Intuniv, which is what's that, atenolol or something. I forget what the generic is. It's basically they're beta blockers, which work great for other things too. And there's a lot of comorbidity. So I wonder how much of this is ADHD plus anxiety that's being dealt with better. And but all day long I look at brains that have been labeled ADHD or anxious or other things. And I often find there's some agreement with labels on the physiology and how it functions, but not complete, and often very coarse and very poor agreement. So I will say that functional patterns that support the interpretation of ADHD, anxiety, and sleep issues tend to show up together more than they show up separately. So you almost always, if you see two of those three things, you almost always see all three: ADHD, sleep issues, and anxiety.
And I know there are potential adverse. I know there are potential adverse effects of the methamphetamines long term on the brain. So I get in the short term, hey, you get like an exam, you're going to do it to kind of get those centers revved up. But long term, what's your take on that?
Yeah, well, it depends on the class of psychostimulant. I mean, some things like Adderall do have a structure similar to methamphetamine. Yeah. Those things we don't know too much about, and it's probably not great long term. The drugs like methylphenidate, Ritalin, that seems to actually be a little neuroprotective, but doesn't necessarily work for everyone, or have all the benefits. When I was just post college or in college, I did have Ritalin, and it made me feel really sedated. I was profoundly ADHD, classic ADHD, in even into my 20s. Not so much anymore, but back then I was. And methylphenidate just made me feel numb. Ritalin, and it just did not work to control my attention. And at that time, as a young quote unquote man, I did take Adderall. It worked relatively well, and I tried it again about a decade or two later, and I guess my liver had gotten too old. I couldn't tolerate the side effects. And I think I'm not so concerned about the short-term side effects.
Right.
I mean,
it's
as
definitely
you
the long-term
say,
stuff. Mm-hmm.
But even the short-term side effects can be fairly profound to a developing person. If your appetite's suppressed, if your sleep's disrupted, if you have underlying cardiac issues, I think that stimulants in general can really provoke a pretty negative set of consequences in the short term. I don't know that we know a huge amount about long-term, but I think that the sort of atypical stimulants like Ritalin, we know are fairly safe longish term because of how long people have been on them. And we know that the biggest risks for a lot of the other drugs is more about either sensitivities, like I said, cardiac or other issues, or there's risk of abuse in stimulants, right? There's often very significant risk of abuse. And I think the problem, the scope of the problem is actually, even though I'm downplaying it a little bit, is actually much more dramatic than we might suggest, because I think ADHD and therefore stimulant prescription is so phenomenally rampant and far outstrips the actual clinical sort of narrow scope focus of pathology that must be addressed. I mean, ADHD is a bucket that has become, huge to swell and catch all kinds of things, especially in school systems.
Oh, yeah.
Where something like half or three-quarters of, in some school systems of kids are on psychostimulants and have these diagnoses, and I don't think the diagnoses match. First of all, I think ADHD is only diagnostically relevant when it's getting in the way, and it's so profoundly overdiagnosed that it's a fraction of the people who have some attention problems under some circumstances that I would call ADHD, capital A, capital H, whatever.
Yeah.
And prescribed for. Because the consequences are high. And this is a medical doctor's, job, of course, to know this, that there are side effects you must balance against the desired effects.
Yeah.
And the side effects of stimulants are not insignificant. They're better than other things. I'm not sure why the beta blockers work. I have a hunch we're going to discover it's more about reticular activating system issues and thalamic activation, up-down states.
Yeah.
Then it's really going to be about, cortical activation and relaxation, if you will. But all those things, regardless of how they're working, are doing short-term interventions. They're not teaching the brain how to not be ADHD, and how to sustain your executive function and sustain a perspective on attention that's resilient and not, reactive. That takes some work, and you can get there, but it's not. It's not rocket surgery. You can get there through mindfulness or meditation, and you can absolutely work on ADHD and other cluster-type phenomena with a short, simple mindfulness practice. In weeks, it will start changing your brain. The research is mounting. You can do a lot with mindfulness to rein back in executive function challenges that aren't necessarily there.
And I think you can learn a lot by the mechanism of how these drugs work. I mean, if you know about the methamphetamine, just the average listener here, they really are going to stimulate serotonin and dopamine and a lot of your catecholamines, norepinephrine, epinephrine. So if that's helping, well, the question becomes, how can we utilize constructive vehicles to increase those neurotransmitters? Also, they block the reuptake too. So they allow more of these nutrients or more of these brain chemicals to sit in between the pre and postsynaptic neuron. The problem is long-term, we start to have more degrading or recycling enzymes that break them down faster. So short-term, it works okay, but in the long term, you start gearing up more enzymes to break them down. So the question, I guess, comes down to, what can we do, on the neurofeedback side, to improve these neurochemicals? And maybe you want to take it to the diet side and maybe even supplement side too.
Yeah, you can do a fair amount. Another benefit of neurofeedback is it really makes your brain more sensitive and sort of reset some of this this acquired tolerance. And we see that in psychostimulants dramatically. A couple weeks into neurofeedback, you have to reduce your dose usually because you're suddenly getting hit with a sledgehammer by your psychostimulants if you're taking them. We also see it for things like cannabis, oddly enough. You suddenly have to ramp your consumption down if you're a cannabis user because your brain is super flexible.
Yep.
But some of the best research is still coming in. I mean, we don't really understand nutrition fully in terms of ADHD, and it's also not a homogeneous issue when it's actually truly present. I mean, so there are several variants, several types of dopamine receptor coding repeats that show up that get classified as ADHD. And some of them make you more hyperactive, but also more resistant to distraction. And some of them make you, more distractible, but less able to focus, but also, also more able to focus rather when you get checked in. So it's a little bit of a confusing space, and therefore what works for one person is not necessarily what works for other people. But those broad classes like mindfulness and neurofeedback work for pretty much everyone. So that's why I start there. There's other things that may work for you. Things like L-tyrosine, which of course is the precursor to dopamine, does work for
Absolutely.
a certain percentage of people as a support to attention pretty profoundly. And I have a hunch that it's working best for those people who've either been on stimulants or who've got, one very sort of narrow subtype of ADHD where it's really about a dopamine receptor, proliferation. And for those people, I think L-tyrosine is actually helping a need. There's no real evidence that supplementing L-tyrosine increases levels of dopamine. But I have a sort of perspective on it where I'm going to let the dopamine system regulate itself because, anything that goes directly at the synapse or increases release of dopamine, things like stimulants, those are always going to be adapted to by the system because they're supraphysiological, they're dangerous, they're alarming to the brain. And so the brain has to adapt and therefore being tolerant, addiction, especially in dopamine. So my perspective on this stuff is always to back up a level in the regulatory space, if you will, and feed the neurons, feed the dopamine neurons what they need to use their enzymatic chain to make dopamine. And then you'll only get more dopamine if you actually need more dopamine in the moment. I mean, I'm really somebody who believes that there's no such thing as a chemical imbalance in the brain. It can't really exist. There's, massive sweeps of regulatory tuning in terms of receptor density and receptor sensitivity and all kinds of other things like that. But my perspective on monkeying with these systems is they know how to regulate themselves. And any ideas we have about what we're doing are going to be really imperfect at best. And, therefore we're going to be trying things that don't make sense. I think we got lucky with something like, SSRIs, I mentioned earlier, Prozac. We now know that Prozac, it does work on serotonin, but not necessarily to increase it. All serotonin neurons have autoreceptors that measure the amount of serotonin in the synapse that they are releasing into the synapse. Mm-hmm. And if SSRIs decrease breakdown and therefore increase synaptic levels of serotonin, the autoreceptor shuts down release. So actually, after you adapt to it, you get sort of lower tonic release of serotonin in your brain than you did before you started taking whatever it was, the SSRI. That sounds like that can't possibly be true because serotonin's the happy chemical and it's antidepressant. It's just not. I mean, if you there's something with anxiety. It's a little more closely linked to serotonin, but the antidepressant effects of the SSRIs, as well as anything else that lifts depression, be it learning new things, be it exercise, be it whatever you're doing. The final common pathway, if you will, of depression relief seems to be increase of BDNF, brain-derived neurotrophic factor,
right,
in the hippocampus, which is all about learning and integrating information. That's kind of what that job is, and that's really the key, I think, the key plasticity, if you will, regulatory factor. So it's all about, I think the name of the game is BDNF. And depression is lifted by raising it through indirectly, many steps back by tweaking serotonin. And the brain responds to that loud signal by, wait, what's going on? And getting a little more plastic and trying to integrate the slightly bizarre signal it's getting from the SSRI is my take on it.
How about B vitamins? How about B? I find B6 or P5P, pyridoxine 5-phosphate is being really important to help convert some of these amino acids in the brain.
All kinds of reasons. I mean, just look at the Krebs cycle. If,
Yeah.
things are back to our high school biology. There's all kinds of amazing things that B vitamins do to the Krebs cycle, specifically some of the, nicotinamide riboside, NADH, in terms of electron exchange. There was some related research. There's a related compound in the Krebs cycle called alpha-ketoglutarate, which recently some research came out of UCLA about a year ago that showed that the anti-aging benefits in model organisms, C. elegans in this case, the anti-aging benefits of alpha-ketoglutarate are like 10 times higher than resveratrol in the same organisms, and through a different mechanism. We know that resveratrol activates sort of the stress response gene SIRT, and that seems to be how they cause, the sort of French paradox and other, animal model documented life extension things. But the alpha-ketoglutarate is operating in a different place. It seems to be tweaking the Krebs cycle somehow, and therefore optimizing energy production. So all the other things that tweak SIRT, like caloric restriction, like cold stress, they do extend lifespan in model organisms, but they do it at the cost of either mobility or reproduction, right? The animal becomes less metabolically active. And that's what happens if you restrict calories in humans too, Eventually we downregulate metabolism, not immediately,
right,
but eventually. And so caloric restriction is the only biohacking modality that's been proven to actually affect aging. But in model organisms, it does so at a cost of metabolic output, and it probably does the same thing in humans. So I'm excited about not only B vitamins, but things like alpha-ketoglutarate. And this is the idea about going after the energy, production machinery a little bit more directly, lubricating ATP production. So B6, B12, and of course we need versions that can cross-convert to methyl states, so ideally hydroxos and things. So yeah, I think a really good complement of B vitamins is kind of necessary. I think that you can also get really specific in a way that we don't really understand yet in terms of what you might need for B vitamins. I mean, there's a lot of that genetic research being done looking at methylation analyses, and that's essentially a study of how B vitamins are used in metabolism of energy and neurotransmitters. That's sort of how those analyses are used, at least.
And when you're talking about B vitamins and B12, though, you have like methyl B12, and you mentioned the hydroxyl and the adenosine. When would you recommend one over the other?
I don't know is the short answer.
Yeah.
And I don't think enough is known. I mean, the methylation stuff, it's not well established. From my perspective, and I come from sort of the autism space, clinically many years ago. There's a lot of focus in methylation in childhood diseases of development, including these, things like autism and Fragile X. There was a lot of focus for many years on energy production and methylation, and some of it seems to do something in some of these people, and some of it is just bad science. And we don't know the line between it, unfortunately, because it's grown out of a population of people who've been trying everything. I mean, when you have an autistic kid, you try everything until you find something that works, and almost nothing works. This is why autistic spectrum population is a pretty good segment of the neurofeedback market, because they discover that it actually affects the brain, and very little affects, profoundly affects the brain of autistic people. But neurofeedback doesn't always, but it can. And that got a lot of attention in that community, so therefore, word of mouth is very high, and that's why there's a big push there. And the same thing's true of methylation. Sometimes the right B vitamin cocktail, dialed into your genes, specifically the versions of the enzymes you make, and that would determine methyl versus hydroxyl versus hydroxyl versus the other versions of B12, for instance. Sometimes it seems to make a difference. I don't know enough about it, and I'm not sure if anyone else does, to really dial it in an authoritative manner.
Are you familiar with pyroluria condition, where you need excessive B6 and zinc levels?
Yeah, I've heard of that. It seems to be related to phenylketonuria as well, where there's some aspartame sensitivities, right? It's a similar genetic, but it's more about elimination of some core vitamins.
Yeah, so they need just accelerated levels of B6 and zinc. And we'll see some of it on the organic acid test, but we give them higher levels of B6 or zinc, and it helps their mood or it helps their sleep or it helps whatever else in their energy systems to function better. Do you have any clinical experience with that?
That's great. I don't, but really this is outside my area of expertise. I sort of do a little bit of personal biohacking in this space, but my understanding of supplements is not as broad probably as my understanding of nootropics. So, B vitamins, when I think about them, are all about, how can I tweak the brain? So I think, B vitamins, I think like cellbutadiene, which is a thiamine, a B1 dimer, essentially gets into the brain and then cleaves. Then you have massive hit of thiamine to the brain. And if somebody came in as an alcoholic, I would think, thiamine, because they have impaired B1 metabolism from drinking alcohol for many years, and they probably have memory issues, and failing deep basal brain like mammillary bodies because of thiamine deficiencies. So I have a very specific, brain focus on this stuff, and not a good understanding of either the, the phlebotomy-driven, if you will, understanding of the biochemistry. It's just not, I work at a very high level with brainwaves. So for me, it's all about tweaking that dance versus reading out the low level outputs, if that makes any sense.
Yeah. So let's shift gears to some of the smart drugs that you've done. I know we kind of have our palette here, whether it's modafinil or piracetam or aniracetam or oxiracetam. What are your favorites? I know in the past you've mentioned you're not a big fan of the modafinil, so I'll let you have it.
Yeah, well, of course, I helped design TrueBrain, and so I'm a big fan of the sort of classic, racetam plus a good choline plus a few other things to support it, and that's sort of what went into the TrueBrain formulations. Personally, I'm still, I still piracetam and either CDP choline or alpha GPC. Still the best 1-2, combination I've ever found. And there doesn't seem to be any downside or tolerance, and these things have been used for years and years and years. So that's the more serious biohackers, stack, or the beginner biohacker stack potentially, but a little bit less racy, less risky, less, poorly understood, would be things like L-theanine. I mean, I'm a big fan. I keep a couple things around my house, my office, and my campsite when I'm hanging out with my hippie buddies. Yeah. And those include L-theanine and ibuprofen. Because L-theanine can pull back over-caffeination pretty quickly, and over-arousal and anxiety and a few other things.
It's doing that with GABA, right?
Yeah, it's very GABAergic. It appears to be very GABAergic in alpha wave production, so it can really, can break some states that aren't comfortable. And then ibuprofen for those folks that have smoked one too many joints or eaten one too many pot cookies and they're, freaking out because of that. Ibuprofen can knock back THC intoxication a little bit and help people who are in crisis. So from my perspective, those are two of my emergency kit, if you will, nootropics, even though ibuprofen's not really a nootropic. In fact, painkillers in general probably should not be considered nootropics because evidence is and I'm talking about analgesic painkillers, ibuprofen, acetaminophen, those sorts of things. The research is mounting that they actually turn off either learning or empathy a little bit in some cases. Now, ibuprofen seems to be the better case these days because in the cannabis research anyways, there's evidence that it eliminates the memory formation problems that happen when you're high, as well as reducing some of the high level of intoxication that people have gotten in trouble with it. So there's a little bit of benefit there, but a lot of these things do actually tweak brain function fairly profoundly. And we don't yet know, what that necessarily is for many of these things. Even things like Tylenol and, ibuprofen, to use the brand names, or I guess Advil's the brand name of that one, but whatever. Even those are not necessarily, things that are without side effects. And there are organ system issues with all those drugs as well. I mean,
elevated liver enzymes.
For ibuprofen and liver for Tylenol. And every year,
gut lining.
People make suicide. Gut lining for aspirin and ibuprofen. Every year, people make suicide attempts with Tylenol and end up in liver transplant wards waiting for a liver because Tylenol is so profoundly toxic to the liver. Not those, but I also think, and again back to the ADHD question, there needs to be a big emphasis on not only systemic inflammation, but supporting lipid metabolism through things like fatty acid supplementation, omega-3s, medium chain triglycerides. You can get good ketone production. For me, the focus on nutrition is shifting more towards getting crap out, bad sugars, bad starch, actually all sugar, bad starch, and leaving in or enhancing the quality fats, which include omega-3s, omega-9s, medium chain triglycerides, usually food sources of those, if at all possible. I'm not a fan of refined oils. I don't love them, and most forms of refining I find either strip things out or leave things rancid. And so I try to get as much as possible from food. It's of course not always possible. And so I do supplement with DHA. That's the only omega that I supplement. And I get it from a form
algae or fish?
Yeah, exactly, algae. True Brain, the capsule form of True Brain still has a DHA capsule in the afternoon packet. And so that's my sort of baseline. Got to get some omega-3s in, because I know my body can cross-convert if necessary. It's not efficient, but if necessary, to make EPA from DHA. And DHA seems to have more brain affinity, so it's a better omega to go after if you're going to supplement. And then I, of course, keep my diet super low in grain-fed anything, including, I don't eat grains. I try not to eat anything that's eaten grains.
Yes.
And that keeps my omega-6s pretty low too, which is, something Westerners, specifically Americans, are quite bad at.
Yeah, and it sounds like you really established to really good fats, kind of a paleo template-esque as well.
I did, I guess. I mean, I didn't know it was called that. I was sort of looking at, initially, of course, I don't know, 20, 25 years ago, I read this book, and it was all about like cycling ultra low and ultra high carbs. And there's some flaws in the theories in the book, but it had really good explanation of how insulin works, and it really stuck with me. And there's all kinds of before that I thought insulin was just this thing that your body secretes in response to blood sugar spikes, so then your cells can suck the blood sugar up and store it either as fuel or lipids, whatever. But I sort of realized at that time that it actually is tied to all these other hormones and other regulatory and modulatory things that cause, catabolic versus anabolic changes and releases of growth hormone and cortisol. And it started me thinking a lot about how probably sort of a time bomb, the typical way of eating, which was repetitively spiking our blood sugar. I mean, the blood sugar question is fairly well understood, but it's also not magical. Let me drop back to a slightly less well understood, but also very similar feature of regulatory systems in the body or brain, which is cortisol in the brain. High levels of cortisol, cortisol responds to stress, and goes up so you can focus and be alert, and a bunch of other things happen in the brain and the body. But in the brain, it watches the range of cortisol, and as it goes up, it responds. When it goes down, it responds differently. If the cortisol level goes up and stays up, response fails. The brain stops responding, and eventually those high levels of cortisol start killing brain tissue. And you know what? That's exactly what happens in things like diabetes. Is insulin goes up and stays up with repetitively spiking your blood sugar until eventually your cells stop responding to the insulinogenic signal, and that causes a cascade of failures at every level in cellular metabolism, and aging, and repair, and growth, and learning, and the list goes on. And so I figured that out about 20 years ago. And yes, I have a slight, problem with ice cream occasionally. I will admit it. But on the days that I'm being good, I'm perfect. And I'm good about 80% or 85% or 90% of the time. And on those days, I'm absolutely damn ironclad on keeping my total carbohydrates below 65 grams unless I've worked out, hugely, like done like a 90-minute lead Ashtanga class and I can barely wipe myself off the ground. Then I might have like an extra 20 grams of carbohydrates right after that in coconut water or something to replenish my glycogen for my, quivering muscles.
Yeah.
But that's when I have a profound physiologic signal of, glycogen depletion. And good note for, levels of carb intake. The human body, if fully depleted, can store about 50 grams of carbohydrates per hour
Right.
as glycogen.
Mm-hmm.
So, it never makes sense to take more than you can store and spike it. For me, anyways, I've sort of figured it out. It seems to be around 20 grams of raw carbohydrate seems to spike my blood sugar. And so my general rule is never more than 20 grams at any one sitting. Never drink my carbohydrate. Seems to spike things faster if it's, sugar in a drink or, even milk or something versus.
How about the glycemic index, though?
Glycemic index is a load of hooey. It's about as accurate as calories, which are also a load of hooey.
How about the glycemic load?
See, that's a valid concept. We just don't know necessarily how foods produce it.
Right.
The rating of food is arbitrary a little bit, but the effect of load on insulin and the carrying capacity, if you will, of occupying enough sensing molecules is a real thing. I don't know what that is, but I do know if you keep your signal of sugar low, very low in the body, the way regulatory systems work is they listen harder. What that means for insulin is increased insulin sensitivity. Mm-hmm. So I don't think it matters if you're in ketogenesis or if you're paleo or primal.
Right.
I think if you stop spiking your damn insulin and you get a sense of what that feels like when you occasionally go over it. I mean, if you spike it every day, you don't notice it. But if you spike it once a week, you know exactly what it feels like to have your insulin go up a little bit above, where you need. Because you have this drunk feeling and you get a little bit sleepy afterwards. But after you adapt to lowish carbs and high fats, energy's rock solid stable. So at some point I figured this out, and about the same time we started figuring out as a culture, if you will, Westerners, how problematic many grains, mass-produced farm grains at least, are.
Absolutely.
in their current format. And I started putting two together and went, oh yeah, that's why my gut feels like, no pun intended, feels like crap all the time, is because of all this, inflammation and sludge moving through my system all the time from eating pizza and whatever else I was eating in the 80s and 90s. So, it ends up being paleo or primal-esque. And I would say, more primal blueprint if we have to tie it to an existing plan than paleo. Because I do think there's a place for dairy in humans, or can be at least. Not every human can handle it, and we have to make space for individual variability. But dairy in a cultured or fermented form, I'm just not willing to give it up.
Right.
And there's, we can make a rationale about historical and ancestral health, although I don't generally make that connection because humans are ridiculously adaptable. So we can point to any population in history and point out something that they've eaten that we couldn't handle now. People are variable. So whatever works for you is really what's important. The insulin is a general rule. The carb loads are rules, the general guidelines, not, ironclad what's going to work for you. But I do think that, cheese and cultured butter and other fermented, dairy can be fairly beneficial to the body. I think it can develop, the gut biome can break it down to useful things. I think it can be a really great source of nutrition. And I'm also of Scotch-Irish ancestry. I'm going to eat me some cheese. Some really, really sharp, crumbly, grab you by the tongue and squeeze kind of cheese. I have to have that. It's built into my body.
And if you can do raw cheese, obviously you get more of the enzymes intact, so you can break down the casein protein, which tends to be the more problematic protein out of them all.
Yeah, and more problematic. And there's also huge, again, genetic variability in terms of can you handle that or not, right? And I am blessed to be able to handle dairy no problem. I'm cursed so that at least current generation, mass-produced chemical shitstorm wheat, I can't handle. And I'm not like half the Americans who seem to have no problem with, mass-produced wheat. I'm of the, at least 40, 50% that seem to have fairly significant issues with eating, bread, so to speak, from commercial grains. So, I was a baker throughout high school and into college, and I'm a phenomenal cook. I'm an amazing baker. I can make you anything you want, name it. I'll walk into a kitchen. If there's ingredients, you'll be happy. But
awesome.
I can't bake. I can't bake with wheat, with gluten, as an adult, essentially, as a grown man, because of the lack of ability to handle it. And this is not a new thing. I didn't know why I had poor digestion as a teen and early 20s person, but I did, and it was eventually because of grains. I have a hard time wrapping my head around us as a society and human creature, culture, developing these big, fat, greedy, hungry brains that needed high starch to really be fueled, with the fact that half the planet seems to be struggling to metabolize starches and grains. Those two things are really incongruous to me. And I can't quite wrap my head around it. And I don't quite believe the full, idea that we've distorted the plants, too profoundly, because humans are adaptable and they seem to be able to adjust long term and quickly to big changes in diet. I just don't understand why we're having such a hard time. This strikes me as a blind men and elephant situation. We're going to discover there's some third factor that's really causative in destabilizing our ability to handle grains. And 50 years ago, that factor was not present. And nowadays it is.
Yeah, I know. If you read Dr. Davis's book, he talks about the genetic modification of wheat, not like the genetic modification we're talking about with like Monsanto, but just we've started
breeding.
off with breeding, just kind of crossbreeding. We had this einkorn wheat that was 9 chromosomes, and then we kind of crossbred it so it can produce more gluten and basically be able to withstand various weathers and conditions. Now, part of that, from what I've seen with the genetic modification and the hybridization, the gluten content has gone up significantly. I think 50%, 75%. So part of it could be just the extra gluten that is present that maybe wasn't there years back.
Maybe. I think there might be something to that, or the gluten may have changed in some form. And the reason I think of this is oats. Oats do not actually have true gluten. They don't have gliadin. They have other forms of gluten-like proteins. Yeah, but yeah, exactly. It's different. And theoretically, if there's no cross-contamination, you have gluten-free oats. Theoretically, people shouldn't have an issue with them. And I'm about as pale as they come ethnically. 23andMe points me at Scotland and Ireland and is not unsure about it at all. I'm one of those people. I'm short, I'm wide, I can climb mountains, I hang out in cold climates and love it. My people ate oats, and I, as an adult, cannot handle gluten-free oats all that well. A little bit, but not all that well. And there's not a lot of those proteins in something like oats compared to true wheat. So I'm not sure what it is. I think there's something else. I think we'll discover that there's something unrelated to wheat completely, unrelated to food completely, that has changed how we do this. I don't know if it's, something in the processing step.
How about Roundup? How much is the glyphosate contribute, you think?
And maybe 20 years of exposure to that, in my traditional Western diet has sensitized me forever to, those types of proteins found in starchy, grains. I handle seeds just fine, but not grains. So, and again, this is an N of 1, and I'm, just an informed consumer here. But I think that, so those glyphosate and other, chemically induced problems, we know those things cause problems. When I was in grade school, I wrote a paper on how DDT made, eggs fragile, and it had been removed from the environment, in like the 70s.
Yeah.
And there's always things like this. Every few years we go, oh yeah, BPA. Ooh, oh yeah, that. Okay, let's get that out of the environment, get that out of our diet. And one of those things is going to interact with the gut environment, the microvia, the genetic expression of the microbiome. Something is going to be made. I mean, there are many times the genetic, material, the chromosomes in our guts that are not human DNA
Yeah.
than that are. You know, the microbiome is incredibly more complex than our own genome. Profoundly more, you know, many times bigger in terms of number of actual genes. And you know, I have a hunch that we're going to find something in there is you know, thrown off by something we're doing as a modern people.
And I guess the next question becomes down to how long does it take for our DNA to adapt? Because I know a human species has been around at some level, 1.8 million years perhaps, and what grains have been here about 10,000. So I guess the question becomes, are all of us adapting at that same rate to be able to handle grains?
Yeah, I mean, it depends on what you mean by adaptation.
Being able to digest.
Yeah, but that might happen quickly. I don't think we fully understand what is necessary in producing those, you know, enzymes and ways to break down, you know, material. Like, for instance, we can't digest cellulose anymore. You know, at one point in our development as creatures, we could eat wood pulp and survive off of it, probably, if we had to. That's no longer the case. We no longer have those enzymes. You know, that swept through the population probably over many thousands or tens or hundreds of thousands of years when we weren't quite yet humans. But other things, you know, your grandparents had an experience that's affecting your genes right now, Dr. Justin. You know, I mean, if your grandparents were in World War II, I'm assuming you're about my age, and they experienced trauma or, you know, stress or anything else, the way your brain and body secrete and respond to cortisol is different than it would be otherwise.
Absolutely.
You know, 2 generations of epigenetic sort of cascade have affected you. So the question about, you know, how quickly does it take to adapt is unfortunately, you know, becoming blurrier and blurrier the more we discover about how the genetic expression of the organism learns and changes and patterns on the environment. You know, the gene for sort of modern big brain size that is in humans, I think it swept through the primate population at the time in something like 20,000 years, which is absurdly fast. I mean, there's no way that could have happened by breeding pressure. You know, it happened through a combination of a bunch of factors, probably, including things like, you know, natural disasters and isolating certain populations.
Right.
And, you know, who knows what else. But, you know, those are individual, actually 2 or 3 identified genes based on brain size. And those swept through the population in a blink on an evolutionary timescale. But we talk about evolution as if it's this massive glacial, no pun intended, thing. And it can be. You know, this is why the fact that I'm bald is a function of glacial evolution. It took a long time for that to show up. But the fact that I was hyperactive as a kid, the fact that I'm sensitive to gluten and other forms of, you know, grains, that might simply be a function of my genome going, dude, that hurt, or I got to respond to that, or that's dangerous. And I'm not sure what it responded to, but it's unfortunately left me unable to, you know, enjoy baking or consuming, you know, really good pizza.
And what's the evolutionary role for baldness? I know you were kind of touching on that briefly there.
You know, I don't know. I've seen a few theories, including things like it allows radiation of heat a whole lot better. Because the brain is ridiculous. I mean, 90% of body heat is sort of escaping through the head. If you're bald, you lose more heat to the top of your head. It allows your brain to cool itself off more. There's also some testosterone, you know, relationships where it might not be an adaptation so much as a, you know, epiphenomena of some other adaptation. Slightly higher testosterone expression or you know, levels in the skin produce a suppression of the follicle, which is male pattern baldness, that sex-linked characteristic. Male pattern baldness, not all hair patterns and all baldness, but you know the one I have is probably a high level of testosterone that reduced the follicle. I'm not sure it produced. I mean, who knows? The more I learn about the brain and the body, the more I'm surprised at how damn efficient every adaptation is. Nothing seems to happen by random, and adaptations that you think serve one feature serve multiple often. So I wouldn't be surprised if at the same time the organism was learning to become more efficient or a heat radiator, the same adaptation made it more, competitive sexually or something. And that meant that genes proliferated. You got both baldness and higher levels of testosterone in some creatures, but for me, I work at EEG, which is a mysterious space. For me, understanding plausible is enough. If we can tweak a system and make it respond, then plausible is good enough as long as we aren't fighting against what is actual. And
Interesting.
We're discovering what is actual in things like follicles. There was a study out a few months ago that showed that they figured out why hair goes gray. And it looks like the same mechanism actually might be related to the sort of key of the suppression of the follicle. There's some evidence, needs to be tested, but there's some theory that was generated by this first finding. The first finding was, oh, look, here's what makes hair go gray. And that actually explains why things like resveratrol may actually plausibly reverse graying in some people who claim that it does. It's not a widespread phenomenon, but it seems to happen. But the same mechanism seems to, suggest suppression of hair follicle. And so we might be like right around the corner from, no more male pattern baldness through cosmetic, pharmacology, if you will, or genetic manipulation, or who knows. But it seems to be we're right around the corner from solving that, if you will. And then I'll have a very firm opinion about how it works.
Got it. So you're thinking,
but right now,
yeah,
doesn't matter.
So you're thinking the resveratrol could be helpful?
I think it probably can be. I don't mind being bald. I guess I'm blessed in that I have a sort of Patrick Stewart shaped head.
Yes.
And so I can pull it off. It's fairly round. There's not a lot going on up there beyond curve.
Yeah.
So I can pull that off. And I wear glasses, so there's something to break up that expanse of flesh. But it doesn't really bother me, and I don't really care too much about it. But yeah, resveratrol will probably, or some related molecule, will probably, unsuppress the follicle. Right now, resveratrol's other uses, right?
Mitochondria.
Resveratrol for mitochondrial support. It seems to suppress estrogenation, or rather aromatization of some hormones. So taking to protect the heart valve. If you're taking other compounds, can be useful. There's a few other like serotonergics. Like you don't want to take 5-HTP and other serotonin converting things and get peripheral nervous system serotonin. That'll do damage. You'll get peripheral neuropathy and damage your heart valve. You want to take resveratrol and things like that to suppress aromatization of hormones. But I bet we're going to discover something else like that suddenly sprouts big, thick, full heads of hair. And
love it.
Will I try it? Sure. Because I actually have a gorgeous, you wouldn't know this, but I have a gorgeous, thick reddish blonde Scottish mane.
Nice.
And it's been 25 years since I've seen it, and I can grow a groundskeeper Willie style mustache and beard right now, and I might. But it'd be kind of fun to go all full lion again at this point in my age. So yeah. I as much as I'm sort of laughing about who cares if we cure baldness, I would probably partake if there was a natural-ish substance I could tweak my follicles with.
Absolutely, I love that. Well, kind of finishing up here, I want to just go through just a rapid question round for you. Just kind of hit these next couple of things off just really quick. Sound good?
Sure.
All right. ADHD. What are the top 3 things you do for that?
Meditate, neurofeedback, and drop sugar out of your diet.
Addiction.
Understand why you're using.
Mm-hmm.
Is it impulsivity? Is it boredom? Is it discomfort with your emotions? Is it brain injuries that lead you to behavior you weren't expecting? Figure out which it is and solve it.
Got it. You're studying for an exam. What are the best things to get your brain revved up for that?
Best thing is to space your practice versus mass your practice, first of all.
Mm-hmm.
Short breaks, ideally with rest and sleep in between them over many days to ensure consolidation. The other thing is to put yourself in the perspective of get to versus have to.
Love it.
So engage with your material because it's fun, and find a way to make it so. And the third thing is don't binge on food when you're studying. Snack very lightly.
Mm.
To make sure you don't end up in a bonk blood sugar wise, which will completely abolish the learning and the studying interest you have for that session.
Love it. Top 3 smart drugs.
Clearly paracetam,
Mm-hmm.
citicoline, and let's say DHA.
DHA.
It's not a drug.
Yeah. Yeah. Basically, the 22 carbon fat in the fish oil. Awesome.
Yeah. It seems to, maybe even vitamin D might even fall into that category. These things are so profound and hitting so many tissues and supporting so much metabolism. I think they upregulate stuff even when it's not noticeable.
Love it. Recovering from brain trauma or TBI.
First thing, don't do anything immediately.
Fast,
Don't
right?
jostle your brain physically or mentally for a few weeks. Then drop the inflammation, which means rest, low sugar, and then you can start doing things like neurofeedback and concentration-focused mindfulness to start waking up all that bruised and delta-rich cortex.
I've seen a lot of stuff on low-calorie diets, especially for a couple of days after the injury.
Yeah, it's just fasting produces a drop in inflammation. So, but basically you got to rest, and you can't even think hard, ideally. You definitely, the damage comes in concussion from the second impact that you get in certainly within 3 to 5 days, but maybe even 3 to 5 weeks after a first significant insult to the brain. There's all these inflammatory cytokines that cause inflammation after the first insult that protect the brain in the short term, but make it fragile, make the tissue very shatterable for days. And if you receive a second impact in that time, the damage is much more profound. The damage carries through the brain, through a solid almost, the way it would like a block of ice, instead of just kind of pushing on a corner of a piece of Jello or something. So you gotta let your brain rest for weeks, 3 to 5 weeks if it's a significant injury, and you can rebuild. If you're somebody who's had a lot of wear and tear, brain fog, irritability, wearing out midday with cognitive fatigue, those are the 3 big signs. If you're somebody who's post-concussive and you're realizing that you still are, months or years later, do something about it. Get some neurofeedback. You can not completely maybe, but you can certainly affect it positively. And there's some long-term risks for remaining post-concussive. We know now that, there's a study out a few years ago, not even a few months ago, I think, or from last year, that showed that high school football players who never played a game but practiced with the team show early signs of CTE, chronic traumatic encephalopathy, from the beginning, brain scans from the beginning to the end of the season without ever playing a game.
Wow.
Simply doing practice. So the amount of damage the brain can actually shrug off is negligible. It's not really supposed to be bounced.
Right.
Or stop or change direction suddenly at 60 miles an hour. It's not designed to go 90 miles an hour on a highway and suddenly stop, or anything else where you're, launched through the world and then suddenly stop. The brain's great at, not that extreme impact, but it fails very quickly over a certain amount of impact, a certain amount of force. And we hit that force all the time. There's a study out 2 weeks ago maybe, a single soccer heading drill, heading the ball 20, 30 times in a few minutes. Memory tests before and after showed a 3/4 drop in performance, severe impairment right afterwards. Now, the study didn't look at long term. It looked at immediate and found it found massive GABAergic. Well, they were hypothesizing GABA as an inflammatory response, but they found inflammatory markers and they found massive impairments in memory right after a drill. And those things we know are things the brain learns from and responds to. So there is no safe level of head impact. You know, if I ever have a kid in high school, they are not going to play football or soccer. And
that was my next question. Would you let your kid play football?
No, I would not.
And what do you think about what's happening with the NFL? I mean, do you think this is just like smoking in the 1950s and it's just we're just waiting for enough research to come to a head?
Yes, absolutely. Yep, absolutely. The NFL will become an also-ran, small network of people who are the bad boys who still continue to do this thing that leaves people, damaged. The NFL will be seen as an organization like Monsanto that has secretly known for decades that they've been, injuring and killing people and have been doing lots with millions of legal dollars to keep that suppressed.
Absolutely.
And we will discover that it just isn't. It was never safe. It will be considered a barbaric time in 50 years.
I think you're right. Well, here, last question with you, Dr. Hill, before we find out more about where everyone can go see you. If you're on a desert island, what's the one supplement or nutrient you bring with you?
All right. Well, does this desert island have coconut trees or not?
It does. So you're going to have the medium chain triglycerides there.
So if I have coconut meat and fat and everything else.
You could probably fish too, so your omega-3s and
I
DHA.
I can fish. I got my DHA. Yeah. Okay.
Sunlight, vitamin D, that's covered.
I think that something maybe beta carotene.
Okay, so vitamin A.
Or no, I don't know. I might get astaxanthins from shellfish.
You probably would.
So what couldn't I get from an island I really needed? I would probably have to say something like paracetam.
Okay.
Actually, let me give you a non-standard answer. I wouldn't bring any racetams with me. I'm on a desert island. I'm gonna relax.
Yeah.
I'm gonna fish. I'm gonna get plenty of vitamin D and good food and maybe grow some vegetables. But if I'm actually on a desert island, high performance is not my survival. I'm going to survive, and once I'm surviving, I think the environmental press of having to live and thrive on a desert island would be sufficient nootropic to keep me functioning at my highest level.
Love it. Very cool, Dr. Hill. Now, people who are listening, they want to find out more about you and about True Brain and about some of the services that you provide. Where's the best place to find more info on you?
Yeah, so folks can check me out at Andrew Hill PhD on Twitter. I think I'm also at Instagram, though it's a pretty anemic page. Peak Brain LA, Peak Brain Institute has a Twitter, Peak Brain LA as well. We have a website, Peak Brain Institute, and of course, TrueBrain.com, TRUBrain.com is the supplement, the nootropic stack that you mentioned that I helped design a few years ago. I'd love if people reach out and ask me their specific brain questions. We all have very unique brains. You put 10 people in a room, there's at least 11 different brains in that room, from my perspective. You really got to share what's special about you and celebrate it, or take control of it and tweak it and address it. So I'd love if folks have, quirky brains they want to share, to look me up and find out some of what we're doing. And, there's lots of ways to take control and change your brain. So let me give you a shove if you're wanting one.
Thanks a lot, Dr. Hill. It was a great talk, and we look forward to chatting with you again soon.
My pleasure, Dr. Justin.
You take care. Have a good one.
You too. See ya.
Bye now.
Bye.
Got a question for Dr. J? Go to BeyondWellnessRadio.com and click the questions button. Then tune in to hear the answer. Also, if you like the show, click below to review us on iTunes. For more Beyond Wellness Radio, go to BeyondWellnessRadio.com.